Welcome back, 8th grade. Well, it's time for us to continue in Chapter 16. We began yesterday by looking at the idea of what a mountain is and what a mountain is compared to a hill. And then we looked at some of the mountains that are considered the tallest mountain in the world. And we looked at how that really depends on how you define the criteria, right? And so today we're going to take a closer look at the types of mountains that there are. Now, I would like for you to look in your book with me on page 417. 417, this is section 16b, types of mountains. All right, now I want to share my screen with you, and I've got to try to balance a few different things on my screen, so that'll be a little bit trickier than normal. But I'm going to share my screen with you now. Now, let me see if I can get pulled up everything I need to get pulled up here. Okay, not that. All right, let's see. Types of mountains. Just give me 1 second. Okay, there's that. And then there's that. Okay, good. Now, it's going to take me just a second to get rolling here. So, types of mountains. All right. Let me press play on this, and then we'll get started. All right, so we're going to be taking a look at how mountains form, how the accretion process, including all the different kinds of collision boundaries, are going to be responsible for forming mountains. All right, on this video, we're just going to be talking about the different kinds of mountains because of these collisions, and I encourage you to refer back to before when we've talked about different kinds of boundary types, okay, because this is just going to be about kinds of mountains. All right, so I'll be focusing more on what mountains exist today. So first kind of mountains I want to talk about are folded mountains. Now, these are the general kinds of mountains that form whenever these collision events take place, and that's basically because of the uplift that happens because of the crust being compressed. And usually these folded mountains are going to have the down terms or roots underneath them because, remember, when you make the crust a little more dense, you're going to end up creating a subsidence of the lithosphere underneath it, unless, of course, there's a stronger magnum intensity underneath those mountains, the way usually happens in places like the Sierra Nevada, for example, where the asthenosphere is thinner and very buoyant. It will be pushing the little steer higher so you can have mountains because of that. But either way, for the mountains, those are the general kinds of mountains you think about, and those are basically synclines and anticlines all put together into these. As you can see in the picture on the top left here, you have these antique lines that show you some examples of places in the world where these folded mountains are going to be around. They're marked locations, basically all the collisions that happen because of these plates coming together. It deforms some of these formations, and they're still forming now, although very slowly as compared to what would have happened during a global catastrophe like the floods. You see some systems in the Rocky Mountains and the Himalayas, and then the southern hemisphere, and you see the Alps and the Andes. Other mountains are formed because of collision events. So these are creating mountains. Another mountain that has to do with collision events will happen when collision takes place at the same time at a divergent boundary or a transform boundary. You have folded mountains that form, but then you'll see some cracking, and you'll get something that looks like this, and they would call those fault block mountains. And basically, you see that there used to be a mountain that was here connected to the mountain, but there's a big gap now, and it's open between them. In this case, you would have a right side and a left side. And this area used to be a mountain range, but it was cracked open, and so you get what's called a fault block mountain. And this will happen when the mountain on either side shifts upward or downwards because of tectonic plate motion after the folding takes place. And so think of it this way: for the mountains which are subsequently cracked and shifted either sideways or upwards in relation to the other block of the mountain are called fault block mountains. And this happens along the edges of transform boundaries or divergent boundaries. And sometimes even because of truss faulting, that kind of will happen in the convergent boundaries as well. So whenever you have a mountain range, there's cracks, right in the middle of the mountain range and then shifts because of fault action, you're going to have what you can call a fault block mountain. And these are some examples now. You have also mountains, and these are happening because of either tectonic or volcanic action that actually pushes the surface higher in a dome shape, which is a three-dimensional fold where all the pieces of the full converge towards the center. And this happens because of tectonic pressure on both sides. Same thing as a folded mountain, but they tend to be isolated instead of happening in a series of sink lines. And this happens with a mountain range, and a lot of times there are tectonic, like the ones you see in the board here, and you also might have them be volcanic ones, like you see here. Volcanic dome, like this, will happen whenever you have a large plume kind of rising on the ground because of a stronger volcanic action that's taking place. And we call this sometimes plutons when they get exposed to the surface. You see one right here, and it's almost just shy of a plateau because that's not flat on top. But these are extremely large dome mountains, which are caused because lava pushing from the bottom. So remember, you can have a tectonic plate folding the earth. You can have subsidence in the uplift happen because of changes in the weight of the surface. And in this case, you can also have the formation of domes. That's very interesting because you have a dome mountain that has a base set on top. So that's actually very interesting how it first got uplifted, but then maybe the magma gave up, and subsequently that causes falling in on the ground later as you go down the mountain or mountains in the waters. All right, so this is the platonic ones, which are caused because of volcanic action. Now, while we're talking about dome mountains, we can say that sometimes people refer to what's called upward mountains, and that can be anything like a folded mountain or a dome mountain or a flat block mountain. It's just basically referring to any time that an uplift event takes place in the surface of the earth. Usually that happens either because of tectonic pressure from both sides compressing, or because of uplift being caused by hotter magma activity, or basically hot magma plume or hot spots that actually creates these domes that we talked about right here. Another kind of mountain that's actually very similar, raised, a lot to do with the dome mountain, is an actual volcanic mountain. And this happens where the volcano actually pierces the surface and causes these large volcanic mountains, as you see here. Volcanic mountains are protrusions of lava that basically sits in the surface of the earth, almost where the magma is trying to punch through the surface, and eventually actually does. And they tend to be very tall. And you see how they have snow on top, and you can see some of the very famous ones here, including Mount St. Helens, Mount Vesuvius, Kilimanjaro, and let's see, Mount Rainier. In Fiji mountain in Japan, you have several of the most famous volcanoes. So these are what we call composite volcanoes, and we'll talk more about those later, but basically they're mountains caused by volcanic activity. You can have some other volcanic mountains which are not really like that. They're not really stratified volcanoes or composite volcanoes, but they're more like shield volcanoes, which happen more because of the lava flow over long periods of time. And you see the actual examples here. And you can have volcanoes, island volcanoes, like you see here. It's sort of like an in-between version. Several kinds of volcanic mountains created by volcanic activity. You also have eroded mountains, which we can see have been worn away because of erosion activity. Those could be either folded mountains or fault block mountains. Mountains of any kind that actually change because of erosion. And you see it happening here in these examples. Just take a look at the photos. Now see where the arrow is, that's not really an example of a shield or volcanic mountain, but more like an actual platform that was just eroded. So you get that as well. But the typical type of mountain, when we mean eroded mountain, we mean this one, for example, in the Appalachian Mountains here in the U.S. So we have, it's been eroded on top and it's covered with soil, which is now allowing trees to grow, which has actually slowed down the process of erosion when you have trees, which is why we still have, these mountains looking as nice as they do. But a lot of the Appalachian Mountains are eroded some. They used to be a little more pointy. It's nice that you have a process that adds soil and allow plants to grow and slows down the erosion. Another kind of interesting mountain that we call the plateau mountains, and you see some flat plateaus here, and they form because of erosion. Sometimes rivers or the waters from the flood would have created a lot of these and carved them out. The whole thing can be uplifted lava fields. Imagine, for example, you have the ground like this, and then underneath the lava, you have ground that has a very large magma chamber sitting underneath. If this uplift event happens, for example, the crust is becoming lighter because of the magma activity is increasing, or because you're having compression from both sides that's causing this to be uplifted. It's possible that this lava field will basically rise slowly to the surface and form a plateau. So that is what actually makes these beautiful structures, which we call plateaus. Sometimes the plateaus themselves might be eroded in these undulating structures like you see here happening on this particular plateau there. But other times you're going to have a plateau that has this dip thing that happens. And you can see you have plateaus being carved by erosions of rivers. But either way, plateaus are volcanic lava fields, which are pushed upward by uplift events. So it's actually very interesting. Here's a few more examples of plateaus. You see the erosion pattern that happens in the Kanto River because of wind and river action. Basically carved and collided a landline of this plateau. And remember, the flood would have caused a lot of this very quickly. You see this large uplift here, plateaus. Notice how the plateaus tint up, and this is actually very well. Just look at these pictures here. You can just see examples like in the Rocky Mountains of the western U.S. because the same type of lift event caused the Rocky Mountains. So it's a good view of these plateaus that form near mountains. Just wherever uplift raises a large magma field higher. So you have another type of mountain here. Forms near divergent plate boundaries. Okay. All right, let me stop that there. Okay, so let me go back here to stop present. And I just want to show you something. All right, look with me at your book. All right, on page 417. I know that was a lot in a very little amount of time, but there's just a lot of information in this section. So if you look with me on page 418, I want you to notice these depositional mountains and how they form by the accumulation of rocks on Earth's surface. So you see a picture there. Mount Fuji in Japan is an example of that. Notice sand dunes on the bottom of page 418. You see a picture of one in the Gobi Desert. They're wind-deposited hills of sand. And we tend to think that they're not very significant, sand dunes. But those in the Sahara Desert in Algeria, they can be as high as 1,400 feet. That's really high. Imagine trying to climb a mountain made of sand. You know how hard that would be? You ever tried running in dry sand? It's very difficult. And they can cover several square kilometers as well. So if you look on page 419, you see examples of hills, moraines, eskers, drumlins. Take a look at those erosional mountains that we've talked about in the video. And then on page 420, you'll see examples of some plateaus. All right. So what I want you to do is I want you to read from page 417, where it starts 6b, types of mountains. And I want you to read all the way through page 426. Okay. It's a lot of information, more than I can cram in one video, but I hope that the video and the pictures I've had you look at least give you some examples of the types. So read it more carefully, look at the pictures, and then answer the questions in your exit slip. All right, so that's it for today with types of mountains, and I'll talk to you later.